Hi again, 3U and 4C chemistry students. So today you've been learning about theoretical yield and percent yield. And theoretical yield you should just think about as being, in theory, what is the absolute most product a reaction should give you. It's definitely what you do on paper with stoichiometry calculations. But in the real world, when you do a lab or you're working in a factory producing product, you get an actual yield. And the actual yield will always be less than the theoretical because you will lose product for various reasons. So just for example, some of those reasons might be that your reactants were impure, like poor quality. Perhaps you had dirty glassware and there was a product in the beaker that caused a side reaction and then used up some of your good reagents to make something you didn't even want. If you transfer between containers, you can lose product, just like when you're baking. Like every time you move from a bowl, there's some batter left behind. So another reason that we'll talk about more in grade 12 is some reactions actually reverse themselves. So they start going back and making more reactants than products. It's called equilibrium. So we'll talk about that in grade 12. So those are a few reasons. But regardless, when all is said and done, you're interested in your percent yield. So percent yield is sort of like it's sort of like a test mark. It's saying how well did your reaction go. So when you get a test back or an assignment and you have a percent, it gives you a really quick visual as to how things went. So this first little example is just a very straightforward calculation. So after you've done your stoichiometry, you've got a theoretical yield from some reaction as being 3.62 grams. And when you really do the reaction, you get 3.18 grams. So the formula that we're going to use to figure out percent yield is mass actual over mass theoretical. And then of course it needs to be a percent. So actually what you got was 3.18 grams because, perhaps you lost some in your glassware, that type of thing. And we're going to divide by what you should have got, your theoretical, and multiply by 100 because we do want it to be a percent. So 87.84%, but we're not going to forget that we do have to worry about significant digits, and you were given 3 for both of your masses, so we are going to round to 3. So not bad percent yield. I'd be happy with that as a test mark. Okay, so more complicated examples, we're just going to apply that to now stoichiometry. And the more practice you get at stoichiometry, the better. So first we're going to do that, and then we're going to figure out the percent yield. So we've got 49 grams of phosphoric acid is reacted with excess potassium hydroxide. So there's lots of that. It's not going to run out. This is what's going to dictate our product. And we, first of all, just want to figure out what is our theoretical yield. So this is what you've been doing all along with stoichiometry. So just to remind you of good format, use the columns to organize your information. So you're given this, and then you are asked to figure out the theoretical yield of potassium phosphate. So I'm actually going to write mass theoretical, okay? And then we'll put a little question mark here. That's what we're looking for. And then later in the part B, we'll see that you are actually eventually going to figure out your percent yield. So I'll leave a little bit of room because we're going to add a few things under there after. So this is just a normal stoichiometry question at the moment. All right, so because we've got masses, we definitely know we need molar masses. So the molar mass here, and I'm not going to go through the work, but you will be practicing these every day still because you need them all the time. And remember 2 decimal places. That was a problem on our last assignment. Every mass you added up would have 2 decimal places, so your final answer needs to have 2, even though 98 is all that would show up on your calculator. And over here, for potassium phosphate, it ends up being 212.27 grams per mole. Okay, so for today, I'm going to demonstrate doing the stoichiometry question in a little more compact way. And it'll also just remind you of the activity you should have done, a gizmo activity where you were kind of playing a game where you got to move some tiles that were conversion factors and place them properly, right side up or upside down, to arrive at the final answer. But they were all like just strung along in a row. So that's how I'm going to do this question today, just to show you that you don't have to use up so much paper. So of course, the only thing we have to start with is this mass. That is what we were given. So we're going to start with 49.0 grams of H3PO4. Now I can't stress enough that now that we're doing stoichiometry, not only is it important to, of course, have your unit so that you know you're canceling out the right thing, but you really need to keep track of what you're talking about, because we know that during stoichiometry, this substance is going to turn into this substance, so we need to know when that happens. All right, so if we have mass, we have to get to moles. So 1 mole of phosphoric acid, we said, has a mass of 98 grams. So the grams are going to cancel. You're going to be left with moles of phosphoric acid. So once you're at moles of something, that's when you get to hop to moles of something else. So if we look up to our balanced equation, we have an imaginary 1 here. So 1 mole of phosphoric acid is going to produce, oh look, it's 1 again. So you might think, I don't need to do it. Yeah, you do. And the reason is because this is going to make your units cancel out. Because at this point, we were at moles of phosphoric acid. That is now going to cancel. Now we're at moles of potassium phosphate. So you do want to keep track of where you're at. And we're asked for a mass. So we're going to put 1 mole of potassium phosphate on the bottom, and then conveniently we already did its molar mass like that. So now that's going to cancel. So this is just like the game, and if you didn't play the game for whatever reason, you should go back because it's great practice, and it's no writing, you're just dragging tiles around. Okay. So now on your calculator, and this is actually the best way to do a calculation, you just do it all at once, and therefore you're never like rounding during the question, which makes you just get off a little bit on your like final answer. So take 49 divided by 98. Push equals at that point is always a good idea after each operation. It helps your calculator stay organized. You know, if you want, you can multiply 1, divide by 1, but I think you can probably skip that. So now you can say times 212.27. And when you do that, you should end up with 106.13 thereabouts grams of potassium phosphate. Now, at this point, because this is a final answer, we should do our significant digits, of which we are allowed 3. Based on what we were given, our molar masses had 4 and 5 respectively. So 106 grams of potassium phosphate. And let's just write here that that is mass theoretical. Okay, so we have solved that question. Now in part B, we're asked for the percent yield. So at this point, we need to know what the actual yield was and we are going to be doing the percent yield. So technically, we could write this up here, but I think we're okay. Isolate means what you actually got, you collected it. So we now know that percent yield is equal to the actual mass divided by the theoretical times 100, which is going to be 89.4 grams divided by, oh, we should have got 106 grams times 100. And that is going to give us 84.3%. And that is your percent yield. So pretty good again. Which means that there wasn't a lot of, loss of product, and there's always going to be some. You should never, ever, ever get a percent yield that is greater than 100, because if you think about it in the real world, how can you gain product if you never had the reactants there in the first place? You can definitely lose stuff, but you can't gain it. So if you ever get a number greater than 100 here, just check to make sure you didn't mess up on your formula and have it upside down. Okay, so that is it for today. So the next assignment for you is you are going to finish questions 3, 4, and 5 on this sheet, and the answers are at the bottom for you to then check your work. Thank you, and we will see you next time.